Hello, in this video, I'm going to show you the hypergeometric indices on a fx-991EX CLASSWIZ. Specifically, I'm going to be showing you how to find probability, how to find the population mean, how to find the population standard deviation, how to find the population variance. All of that I'll be showing you how to find on a hypergeometric probability distribution on this particular calculator. First, make sure we're in the right mode. So hit Menu and the number 1, and that's usually how you'll start off. Now, take a look here. An example would be a bowl has 10 white beans and 16 black beans. If I reach in and grab 7 beans without replacement, means I just grab them all at one time, find a probability that in my hand, I have exactly 4 white beans. So if you look at it, I've got a total of 26 beans, 10 of which are going to be white, and the rest, 16, are going to be black. I reach in, I grab 7 beans. Now, when we're finding probability, like I am in this case right here, we need to go one more step down. So what's the probability you have exactly 4 white beans? So I have to pick the white beans from the white beans. So I'm picking 4 of the white beans. And that means if I have exactly 4 white beans and 7 beans in my hand, the rest have to be black. Because they only have white and black. So if they're not white, they have to be black. So I have to have exactly 4 white beans and exactly 3 black beans. Out of a total of picking 27 beans, out of 26 beans, picking 7 of them. So the probability that you would write, let me just mention a couple things real quick. When I say the words without replacement, what that means is basically my probability is going to be dependent. It means it depends on what I've chosen before. To pick a second white bean, depends on whether I've chosen a black bean or a white bean. So, it depends on what's happened in the past. So that's generally a hypergeometric. So using this as a little bit of a pattern, what I can do is the probability of the P of x or F of x, depending on the author, would be 10 combination 4. And it's a combination because these are just white beans. They're not individually marked or anything like that. So it doesn't matter which of those beans you pick first or second. So it's a combination. So 10 combination 4 times 16 combination 3, all divided by 26 combination 7. And so historically, we've written it this way. 10 over 4 in parentheses times 16 over 3 over 26 over 7. The way we've written it historically. Now, because calculators, when you put them in a calculator, they look differently than that. And we do it this way. So that would be 10 choose 4 times 16C3 over 26C7. So that would be, we would turn on our calculator, and these are all combinations which are above the division key. So I would go 10, shift, hit the division key, which gives you the C, and 4. So that's how you do 10C4. Times 16, shift, division key 3, times 16C3. Divided by 26, shift, division key 7. Now, so this is the way the calculator will look many times. Equals 588 over 3289. But that's not what I have here. How do I know if that's right? Well, this goes from standard, this button goes from standard to decimal and back and forth. So if I were, so here above the division key, the S to D button, if you press it, it gives you the approximation. 0.178777744. This says 439, so it just gives you a few less decimal places. That's okay though. So it gives you that value. If you press this S to D again, it gives you a reduced fraction and goes back and forth to a decimal, reduced fraction, and so on and so forth. right. So that's probability. Now we're going to be getting into not probability, but population, sorry. The population mean, the population mean, the population variance, and population standard deviation. So let me talk about that for a second. In order to need the population, so if I need something that has to do with population, population mean, population variance, and off camera right now is population standard deviation. To do that, I need these top four numbers, M, W, B, and N. Now, I'm using the numbers M, W, B, and N of my own accord. There's nothing written in stone about those. It's just locations. So I'll be talking about white beams. So I want to put white on the right, white on the left, I'm sorry. And I don't want to talk about black, so I'll put blacks on the left. Whatever you want is like white. It stands for white and stands for want, the W. So I'll be using M, W, B, and N. And I'll replace those numbers every single time I get to use it. So for instance, the population mean, mu, is equal to N times W over M. So that'd be 7 times 10 over 26. 7 times 10 over 26. So I would clear this and go 7 times 10 divided by 26 equals 35/13, which I'll hit my S to D button, standard to decimal, 2.69 to 307, so on and so forth. So here, I would go ahead and do the population mean. Now, I'm going to pick this up a little bit because I want to show some stuff. And right there, that's good enough right now. I'm going to use the population variance just so it's easier, hopefully, to see. And population variance would be N times W over M times B over M times M minus N over M minus 1. So you need all of those values. So N times W over M is 7 times 10 over 26. We discussed that when we talked about the population mean. Times B over M. B is 16, M is 26. So 16 over 26. And then M minus N would be 26 minus 7. And M minus 1 would be 26 minus 1. So to clear this up a little bit, let's go 7 times 10 is 70, times 16, 26 minus 7 is 19, times 26 times 26 times 25. And so however you do it, the way I would do it is here. I would just multiply those numbers together, 70 times 16 times 19 divided by, open parentheses, 26, and because it's 26 times 26, it's the same thing that 26 is being squared, so I hit the x squared button. Times 25, close parentheses, equals, and hit the S to D, 1.25917. Perfect. Now, some people don't like it this way. Some people think it looks better if you just see it the way it looks, so let's do it that way. I'm going to show you a different way to do this exact same problem using the fraction key. On the fraction key, hit that box over box key. On the top, I'll hit 70 times 16 times 19. Go down to the bottom, using the bottom arrow, go to the bottom, and go 26 squared times 25. Equals, it gives me the same number, hit S to D, gives me the exact same number. So it really doesn't matter which way you like. If you like one way better, stick with it because it's good. Now here's what I want to show you. I want to go up a little bit more and talk about the population standard deviation. As we've mentioned before, the standard deviation is just the square root of this. See, I have this number, the 1.259 number. I have that on here. So I just have to take the square root of that value, and I can do that simply by hitting square root button right here, hit square root, and then hit ANS. Kind of looks like Vans, like Vans shoes. Kind of looks like that. But anyway, we hit equals there, and it gives you that 1.22128, et cetera, et cetera. So that would be the simplest way, is to find the population variance, then take the square root of it to take the population standard deviation. But maybe you don't want to find this variance first. Well, if you notice, 70 times 16 times 19 over 26 times 26 to 25 is the same number here. So let me show you a couple ways to do that. Hit the square root button, and what I would just do, go 70 times 16 times 19 divided by open parentheses 26 squared times 25 close parentheses. So it's the same thing I did here. I did exactly these steps. The difference is now being is that when I did it here, I hit the square root first. It equals, and it gives me the exact number. Some people, again, don't like that doing it this way. And so it looks kind of more like this. And that's okay. We could do it on this calculator. You hit square root, and then you would hit the fraction key. On the top, you'd go 70 times 16 times 19. On the bottom, scroll down to the bottom, you go 26 squared times 25 equals exactly the same answer. So basically on this particular video, I showed you how to find probability, the population mean, population standard deviation, population variance, on a hypergeometric probability distribution. Once I've been given the formula on a fx-991EX CLASSWIZ. Thank you so much for listening. I hope you have a blessed day. Thank you so much for watching, and I will talk to you later. Bye-bye.